to our rocket project.
My name is Kaylin Zhao, and my partner is Rose Usman.
This project wanted us to design a rocket in a simulation software, build it and launch it, and see how the different features we added to it would translate into its function. We were given a model rocket kit to put into OpenRocket. However, we were given the 0.74-inch diameter one, which did not match the dimensions in PLW, so we had to do more figuring out of what the parts were. So we looked at the numbers in the manual to get the part type. Other than that, we just had to figure out as best we could. After performing the OpenRocket simulation, we were able to find the green check mark, which meant that it would be safe to fly. This gave us approval to build, and then we could proceed in doing so. It was very simple. All we would do is follow the instructions in the kit, and that meant we used the adhesive to glue the piece onto the nose. Then what we did different from the kit is that instead of using their wings, we used or made the wings that we did in OpenRocket instead. And then, of course, sanding them down to keep them all unique. Not unique, but the same. And then we made the equally distant. Glued one on, let it dry. Put in a spacer while it was drying. Attached the rest of them. Added the straw that kept it in alignment with the launch pad so it could fly straightly. And then I was about to put in the firewall and proceed with the rest of the rocket build when I realized I had misplaced the spacer and put it at the front end instead of the back end. Luckily, I was able to join up with Kaylin and finish the rest of the rocket.
From there, we started to prime our rocket for the acrylic paint we're going to put on it. And as Rose said earlier, we began to use my rocket, which I had been previously making using the exact same steps that Rose had been doing. So as you'll see on the next slide, we began to paint our rocket in a beautiful blue color, and then we had to attach our C65 motor to get the rocket ready to fly. After inserting the spark plug and the engine, it was about ready to be launched, so we went outside and we began to set up for launch. For our center of gravity test, we determined the center of gravity balancing the rocket on our finger, then swung it on a circle to see how the rocket would behave. It proved that our rocket would have a good center of gravity and would be safe to fly. During the launch, we had two different people facing each other opposite of the launch pad with the Estates Air Track, Alta Track, which we used to measure the angle of our launch. So with those two people recording the angles, had two people recording the launches via video and another person noting down the angles and the person who would be lighting the rocket.
This is actual footage from our launch.
I'm looking at it right. Just.
Yep. 3, 2, 1. Hold it now.
As you can see, it did not fly straight as intended, and let's see why.
So, onto our rocket analysis. After we began to measure our angles using the projector gun, we calculated our angles to be 25 and 20 respectively on each side, each a distance of 30 feet away. So the average altitude, despite the complications, was about 12.5 feet.
Which is a lot less than the simulation said it would be, which is reasonable because when we recovered the rocket, we saw that the straw that was meant to detach at launch was actually still attached. This may have turned the trajectory, causing it to power itself in a circular motion, which I believe may have led to it crashing. And then, because the engine was not able to do its job, it combusted inside the rocket, leaving us unable to recover the rest of the rocket. And that is our rocket presentation. Thank you very much.
Thank you.